What if an engine was so powerful, so completely dominant over everything it competed against, that the people running American Motorsport had no choice but to sit down and rewrite their own rule books just to stop it? What if the engineers who built it knew they had a secret weapon inside that engine? A specific camshaft setup that unlocked brutal power the competition simply could not match. And they kept using it, kept winning with it, kept embarrassing every rival who showed up to race against it, right up until the government itself stepped in and forced them to stop. In the late 1960s, Chrysler's engineers had exactly that weapon inside the legendary 426 cubic inch Hemi Fiv 8, a specific solid lifter camshaft configuration that gave the Hemi's already fearsome engine a razor-sharp power delivery that made it behave differently from anything else Detroit had ever produced. NASCAR banned the entire engine. The EPA strangled it with emissions laws, and by 1972, one of the greatest American performance engines ever built was gone from the showroom floor forever. This is the true, documented story of the camshaft trick that made the Chrysler Hemi untouchable, and the forces that conspired to kill it. If real automotive history like this is what brings you here, hit that subscribe button and tap the bell icon right now, because this channel covers true stories exactly like this one every single week. To understand why the Chrysler Hemi's camshaft setup was so significant, and why it eventually became something that had to be eliminated, you first need to understand where this engine came from and why it existed in the first place. In late 1962, Chrysler's president Lynn Townsend issued a direct order to his engineering department. Pontiac was dominating both NASCAR's superspeedways and the NHRA's drag strips, and Townsend wanted that dominance stopped. He wanted a winning engine, and he wanted it fast. Willem Bill Weertman, Chrysler's manager of engine design, assembled a small team to answer that order. The team included racing program coordinator Tom Hoover, who would later become known as the father of the Hemi, designer Frank Bjalk, and manifold engineer Forbes Bunting. Working against what must have seemed like an impossibly tight deadline, this team produced an engine that would change American motorsport permanently. The engine they created drew on Chrysler's own institutional knowledge, stretching back to World War II, when the company had developed experimental aircraft engines. Using hemispherical combustion chambers, a design where the top of the combustion chamber is shaped like half a sphere rather than a flat surface, this hemispherical design allowed for larger valves, better airflow through the engine, and more efficient combustion than conventional engine designs of the era. Chrysler had already used this concept in their Firepower Fiv 8 of 1951, their first civilian Hemi engine. The new racing engine built on that earlier experience and took it to a completely different level. The result was the 426 cubic inch Hemi Fiv 8, displacing the full 7 liters that the FIA had just approved as the new upper limit for engine size in 1963. With a bore of 4.25 inches and a stroke of 3.75 inches, cross-bolted main bearing caps for maximum bottom-end strength, drop-forged connecting rods, and a forged steel crankshaft, this was a race engine through and through. And at the center of everything the Hemi did, the component that made its power delivery so savage and its performance so far beyond what rivals could match, was the camshaft. The race version of the 426 Hemi used an aggressive solid lifter camshaft with 312 degrees of duration. Understanding what this means requires a brief explanation of what a camshaft actually does, and why the difference between solid and hydraulic lifters matters so enormously to a performance engine. A camshaft is the component inside an engine that controls when the intake and exhaust valves open and close during each combustion cycle. The shape of the lobes on the camshaft, how high they rise and how long they stay open, determines how much air and fuel mixture gets into the engine, and how efficiently the burned gases escape after combustion. A more aggressive camshaft profile with higher lift and longer duration allows more air and fuel into the engine, and produces more power, particularly at higher engine speeds. The trade-off is that an aggressive cam makes an engine rougher at low speeds, harder to start, and less suitable for street driving. It produces that distinctive choppy, lumpy idle sound that gearheads still associate with serious performance engines to this day. The kind of technical documentation that would have been used in the Highland Park dyno rooms to build the most feared engine in Detroit history. Solid lifter camshafts, as opposed to hydraulic lifters, use mechanical components that do not compensate for changes in valve train clearances as the engine warms up. They require regular adjustment and produce higher valve train noise, but they allow the most aggressive possible cam profiles to be used, and they permit the engine to operate at much higher RPM ranges without the valve float problems. The hottest performing engines of the muscle car era, including the race version of the 426 Hemi, use solid lifters precisely because the cam profiles required to produce the highest power were simply unsuitable for hydraulic systems. The 1964 racing season proved immediately that Chrysler's team had built something genuinely extraordinary. At the Daytona 500, Hemi-powered Plymouth Belvederes took the first 4 finishing positions, with Richard Petty winning the race. On the NHRA drag strips, Hemi-powered Dodge and Plymouth package cars were rewriting elapsed time and speed records in the Superstock and Factory Experimental classes. The 426 race Hemi, with its solid lifter camshaft, its 12.5-to-1 compression ratio, its aluminum cylinder heads, and its cross-ram Holley carburetor setup, was simply in a class by itself. Nothing could match it. NASCAR's response was swift and, from Chrysler's perspective, completely unjust. For the 1965 Grand National season, NASCAR declared that any engine used in competition had to be homologated. The race Hemi had been produced in strictly limited quantities. It was not a production engine that any customer could walk into a dealership and order. Chrysler sat out the 1965 NASCAR season entirely. While NASCAR had forced Chrysler off the superspeedways, the company redirected all its racing energy into NHRA drag racing, where the Hemi continued to dominate with a fleet of specially prepared A990 lightweight cars. But the pressure from NASCAR's homologation requirement was real, and Chrysler's engineers set to work during 1965, developing a version of the Hemi that could be offered to the general public. The solution? The Street Hemi. To make the race engine suitable for street use, Chrysler's engineers made a series of deliberate compromises. The compression ratio was reduced to 10.25-to-1, allowing the engine to run on pump gasoline. The aluminum cylinder heads were replaced with cast iron units. The cross-ram Holley setup was replaced by twin inline Carter, A-key FB 4-barrel carburetors, and a significantly milder solid lifter camshaft. The Street Hemi was officially rated at 425 horsepower DK, numbers that many believe were deliberately understated to keep insurance companies from refusing to cover the cars. With the Street Hemi now a legitimate production option, NASCAR had no choice but to allow Chrysler back onto its tracks for the 1967 season. And the pattern of Hemi dominance immediately resumed. For the 1968 model year, they made a meaningful change to the Street Hemi's cam profile. The duration was increased to 284 degrees with higher valve lift. The 68 and 69 Street Hemi engines retained their mechanical solid lifters with this more aggressive cam grind, giving the engine a noticeably sharper character than the earlier Street Hemi. This was the Hemi at its most refined and aggressive. This specific combination gave these 2 model years a reputation that still commands enormous respect and premium prices in the collector car market today. Then everything changed for the legend of the Hemi. For the 1970 model year, Chrysler switched the Street Hemi from its solid mechanical lifters to hydraulic lifters, using a different camshaft grind matched to the new valve train. The official reason given was emissions compliance and reduced maintenance requirements for street customers. Solid lifter camshafts require periodic valve lash adjustments that hydraulic systems handle automatically. From an engineering standpoint, moving to hydraulic lifters simplified ownership for customers who were not professional mechanics. But from a performance standpoint, the change marked the beginning of the end. The hydraulic lifter cam of 1970 and 1971 could not be ground to the same aggressive profile that the solid lifter setup had permitted. The edge that the 1968 and 69 cars had possessed was gone, and the forces that had been gathering against high-performance engines since the late 1960s were now impossible to stop. The federal government's Environmental Protection Agency had been establishing increasingly strict emission standards throughout the early 1970s. The compression ratios that performance engines needed to produce their rated power were fundamentally incompatible with the lower-octane, unleaded gasoline that new emissions regulations were requiring. Insurance companies across the country had been steadily raising premiums on high-performance vehicles to levels that many buyers could not afford. The muscle car buyer, who had been the heart of Chrysler's performance market, was being squeezed from every direction simultaneously. And in 1972, the combination of the EPA's stringent new federal emission standards, NASCAR's continued political maneuvering against the Hemi and stock car competition, and the commercial reality of building an extremely complex and expensive engine for a shrinking market resulted in the final nail being driven into the coffin. The 426th Street Hemi was discontinued after the 1971 model year, with the last examples produced for the 1972 model year being race-only units for NHRA competition. The numbers tell the story of just how rare and significant this engine and its camshaft history truly are. Across the entire 7-year production run of the Street Hemi from 1966 through 1971, only around 9,000 examples were ever installed in Dodge and Plymouth vehicles. Of those, the 1968 and 1969 cars with the solid lifter setup and the more aggressive cam grind represent an even smaller subset. The cars that carried the Hemi at its absolute sharpest in street-legal form. An original, numbers-matching 1968 or 69 Hemi car today commands prices that reflect exactly what the market understands about what those specific cam specs meant. The difference between a solid lifter Hemi from 68 or 69 and the hydraulic lifter cars that followed is a difference that serious Mopar collectors have understood for decades. The Hemi's influence did not die with its discontinuation from the streetcar lineup. The basic architecture of the 426 Hemi, with its hemispherical combustion chambers, its canted valves, and its fundamental engineering DNA, became the foundation for the nitro-burning top fuel and funny car engines that still power the fastest accelerating vehicles on Earth today. Modern NHR top fuel engines, producing over 10,000 horsepower, trace their direct lineage back to the engine that Tom Hoover's team built in late 1962 under Lynn Townsend's order to go win races. What Chrysler's engineers had created was not just a powerful engine. They had created something that the entire establishment of American Motorsport felt compelled to legislate against, regulate into submission, and ultimately eliminate from competition and the showroom floor. The specific camshaft setup that gave the 1968 and 69 Street Hemi its razor edge was the final flowering of an engineering philosophy that prioritized winning above all else. A philosophy that the regulatory environment of the early 1970s simply could not allow to continue. If this kind of real, carefully researched automotive history is what you come here for, make sure you are subscribed to this channel, because every single week we bring you true stories exactly like this one. Thanks for watching, and we will see you in the next video.